Today we're going to talk about input-output tables. I like to think of an input-output table as a magical number machine. One number goes in to the input-output table, some magic happens inside, and another number comes out. Let's look at an input-output table as an example. So this right here is an input-output table. An input-output table represents how a rule is placed on a value, which is the input, and then it results in a different value, which is the output. An input is the number before the rule is applied, and an output is the number after the rule is applied. Every input-output table has a rule. Something happens between the input and the output, and we have to figure that out. This is why I like to think of it as a fancy number machine. If I have the number 1 go into my machine, something happens, some magic happens, and then the number 3 comes out. So, how can I figure out the rule for an input-output table? First, I look at the numbers. So I start with number 1. And I notice that this number is getting bigger. It turns into a 3. I know that if I'm making a number bigger, I'm going to be adding or multiplying. Those two operations make a number bigger. I notice that my 2 turns into a 4, and the 3 turns into a 5. So something's happening here where the numbers are getting bigger. If I think of this like a magical number machine, the number 1 goes into the machine, some magic happens, and the number 3 comes out of the machine. I have to figure out what the magic is. So I know that the number is getting bigger, which means I could add or multiply. I see that 1 turns into 3. That's getting bigger by 2. 1 plus 2 would give me 3. Let's see if the rule applies to the next values. My next number is 2. If I add 2 plus 2, that would give me 4. So the rule applies here as well. The next value, 3, if I add 2, that gives me 5. So the rule applies here as well. In order for the rule to be correct, I have to apply it to every single value. It has to work every single time. So I found that this rule is plus 2. The magic that's going on in my magical number machine is plus 2. And I know this is the rule because it works every single time. Again, if it works every single time, then you found the right rule. But if it doesn't work every single time, that's not the rule. Let's try another one. So here I have another input-output table. Remember, the input is the number before the rule is applied, and the output is the number after the rule is applied. If I think of this as my magical number machine, the first number to go in is an 8. Some magic happens on the inside, and the number 5 pops out. So I'm noticing 8 turns to 5, 9 turns to 6, and 10 turns to 7. These numbers are getting smaller, and I know that to get smaller, I'm going to subtract or divide. Those two operations always make a number smaller. I just have to figure out, how are they getting smaller? Are the inputs being divided by something, or are they being subtracted? So I'll look at my first rule. 8 turning into 5. That's getting smaller by 3. I'm subtracting 3. 8 minus 3 would give me 5. Remember, the rule has to apply to every set of values, so I need to check every single one. Let's see. 9 minus 3 would give me 6. The rule works here as well. Let's check the last one. 10 minus 3 gives me 7. The rule works here as well. Since the rule works on every single value, I have found it. The rule is minus 3. So the rule for this input-output table, or my magical number machine, is minus 3. If I stick the number 8 inside, 3 is taken away, and the number 5 pops out. Let's try identifying the rules on some input-output tables together.